So hello everyone and welcome back to the second lecture in the topic of CNN. In the previous lecture, we have covered the basic of convolutional neural networks and we were able to gain a very basic intuition that how this particular architecture works. We also gained some understanding around the basics of an image or how the pixels work in order to form an image, and we had a good comparison between ANN and CNN architectures. This particular lecture is going to be all about understanding the convolutional operation within a CNN architecture in details. So we are going to cover the architecture from absolute scratch. We will interpret it in such a way that the image on your screen should not be looking confusing anymore once you finish this lecture. So first of all, this entire CNN architecture can be divided in two basic parts. First will be this part, this particular one, and the second will be this particular part. The first part is called convolutional layer. It is the layer where we have the concept of feature maps that does the operations like feature extraction. And by the way, we are going to understand both these things within this lecture only. And the second part of this architecture is called fully connected layer or fully connected neural network. So basically it is nothing but just the artificial neural network, the ANN architecture that we have studied previously in this deep learning playlist. So now let's pay more attention and we will try to understand both these layers, the convolutional layer and the fully connected layer, in more details. So let's start first with this convolutional layer. This layer is responsible for doing two types of operations. First will be convolution, which is here, this one, and here, this one. So the first thing it does is the convolutional operation. The second thing that it does is pooling, which is happening over here and here. And for this particular lecture, we are going to pay more attention on the convolutional part. We will cover pooling in a separated lecture. But just for the time being, if I would have to give you an high level understanding around pooling, then simply it is a function that works in such a way that it reduces the computational cost when you are using a CNN architecture. But for simplicity purpose, let's avoid pooling as of now because, as I said, we will discuss it separately in a dedicated video. And coming back to the second part, which is a fully connected neural network or the fully connected layer, I guess that you would be anyways familiar with this if you have been following this deep learning tutorial from start, as we have already discussed the concept of artificial neural networks, where we have understood the concepts of perceptrons or neurons, or what is the concept of a multi-layer perceptron. So it is exactly the same thing, nothing else. Now let's try to dive deeper into this first part of the architecture, which is convolutional layer. And let me try to give you some understanding that what exactly it is doing from starting to end. If you remember, in the previous lecture, we discussed the concept of edges or primitive features. So for example, if we have an image of number 9, let's say, then of course the features for this particular image or this particular number could be this circle, okay, maybe a vertical line like this, and then a horizontal or slant line like this. So we can form the image of number 9 with the help of these three features. And if we had to further break down these features like this particular circle on the top, then this will be made up of some primitive features or edges like this. Okay, these edges are actually forming the circle on the top, which is there on number 9, or the object 9 which we have on the image. Similarly, next primitive feature will look like this, and maybe next like this. And combining these primitive features together, we will have the feature like this complete feature, then this detailed feature, and then maybe this. So anyways, if you have covered the previous lecture, then you will have a detailed understanding that what I'm trying to say over here. And when we are talking about the convolutional layer, what it is doing from the starting, initially it will try to detect the edges like this, maybe an horizontal edge, a vertical edge like this, something like this, okay? And as we move ahead within the convolutional layer, it will start recognizing more complex features like this, okay? And finally, towards the end, it will completely understand that how the image is being formed. So as a whole, this is exactly what convolutional layer is doing or performing. And going ahead within this lecture, we will try to understand mathematically that how exactly it is doing this. So let's move forward now. Before we move ahead, I would like to take some time to emphasize on the need of understanding image basics. You should have some understanding that how an image is formed pixel by pixel and how each and every pixel will have a value assigned to it. Like the darkest one will have the lowest value, the brightest one could have the highest value. The value will always range between 0 to 255. So obviously I'm assuming that you have covered the previous lecture, and if you have, then you will completely understand what I'm trying to say here. Because we have covered the basics of an image or the idea of pixels in a lot of details within the previous video. And this was about a grayscale image. Similarly, if we talk about the nature of a colored image, which you obviously know is formed by the combination of three channels, red, blue and green, which is also called as RGB channel. In fact, if we do a simple Google search, we will have very nice results that will help us to understand. So let me pick this one for you. This will help a lot. So you can see we have three channels over here, red, green and blue. Each and every channel is made up of pixels. For simplicity, we have 3 by 3 over here. I'm talking about the size or resolution for each and every channel, and every pixel has different types of values assigned to it. And with the combination of these three channels, we can actually form hundreds and thousands of different types of colors that we usually see on the electronic screen like mobiles or laptops. So as a whole, what I'm trying to say is that you should have a basic understanding around the image fundamentals or the idea of pixels. And if you are good till this point, then of course we can move ahead. So far we have discussed a lot about edge detection in an image, and we have discussed that how the edges or primitive features combined together will form more complex features, and those features will form the object. And here is another example to understand the same thing in more details. So on the left hand side we have an image, and on the right hand side we have two images, which is telling you that how vertical edges and horizontal edges are being detected. So please pay very close attention and you will not require any further explanation on edge detection. Or I should say that what are edges with respect to an image, because obviously we will have to discuss that how edge detection is being performed in a CNN architecture. But for the time being, you should be absolutely clear in terms of what are edges actually. So again, coming back to this particular image, the first one on the right hand side, pay very close attention and you will able to understand that this particular image is actually grabbing all the vertical edges from the image we have on the left hand side. Similarly, the second image on the right hand side is actually detecting all the horizontal edges. So over here we have all the vertical edges being detected like this one and this one. And on the second image, it is focusing more on the horizontal edges like this, like this one here, then this, these ones. Okay, so obviously this interpretation should be very easy to understand. But if I'll ask you that what are edges exactly in terms of an image, then that also would be a very interesting question. If I'll have to explain in a very simple way, then I will say that edges are nothing but the change of intensity in a given image. I'll try to explain what I'm saying. See, this particular area in the image is black, right? Then if you will observe, then suddenly from this vertical line, the intensity is changing. It is turning from black to white. Again, from this particular area, it is changing from white to black. Again, it is changing from black to white, then white to black. So there is a change in intensity. And when we are capturing edges, then we are doing nothing but we are capturing these changes in intensity, whether it is horizontally or vertically. So I hope that now you have become pretty much comfortable with the concept of edges. What are they? What are vertical edges? What are horizontal edges? If yes, then we are fine to move ahead. And now comes the most interesting part of this lecture. We are going to understand mathematically that how these edge detection is being done or being performed in a CNN architecture. So over here on the left, we have a 6 by 6 matrix, which is representing a very basic image that will look like this one. Okay. A very simple and basic image that looks white on the left side, gray or dark on the right side, and we have a vertical edge in the middle. That's it. That's the image that we have. And if you will pay close attention on this matrix, then you will be understand that how exactly it is forming this image. On the left part of the matrix, we have the same intensity, which is indicating to this white area. And suddenly, on the right hand side, the intensity is changing from 10 to 0, which is forming this gray side of the image, which is the right side. And since in the middle, this is that particular area where the intensity is being changed, this is why on the image as well, we have the edge in the middle. Anyways, visually, it is very easy to interpret this image and say that we have an edge in the middle of the image, which is a vertical edge. But how exactly computers are detecting these edges? Computers that understands nothing but only numbers. So this is where we need to understand about the concept of filters or kernels. So this 3 by 3 matrix that you can see in the middle is something that we will call filter matrix or kernel matrix. And this particular filter is designed in such a way that it will be able to detect the vertical edge. And now we are going to understand how. So please pay very close attention, because this particular part is going to be the heart of this particular lecture, where we are going to understand about convolutional operation and how it is happening on a mathematical level. So as a first step of the convolutional operation, what we do is we take this entire 3 by 3 matrix and we place it on the image that we have like this. Okay, this is the first step. The second step is to do element wise multiplication, which means this element will be multiplied with this element. Similarly, this will be multiplied with this will be multiplied with this, and so on. This will be multiplied with this. The same way, we will multiply all the elements from this particular area of the image with the respective elements from the kernel matrix. And after doing the element wise multiplication, we add all the elements and the result will be placed over here. So let me do it manually for you. I'll do it once so that you can have some understanding that what I'm trying to say here. So let me erase all this very quick. Okay, first of all, these 3 elements multiplied with these 3 zeros will give us only 1 0. These 3 elements multiplied with these 3 elements will give us 10 plus 10 plus 10, which is 30. And these 3 elements being multiplied with these 3 elements will give us minus 30, and the result will be 0. And this is what we have over here within the first cell. And once this particular action is being performed, then comes the next step. So what we do now, again we will take this filter or the kernel matrix and we will slide it on the image from the first position to second position like this. Again we will do the element wise multiplication. We will add up everything and we will have this result. You can try to do it by yourself and you should be getting 30. Again, as the next step, we will move the filter from previous position to the next position like this. So if I'll remove the previous 2 position, then this will be the new area where we are doing the multiplication this time. And again, the result will be placed over here after doing the addition. And again, as the last step, we will place the kernel or filter matrix over here. And after doing the element wise multiplication and addition, the result will be put over here. Once we are done till this point, since we can't move towards the right any further, what we will do, we will again go to the left and we will come one step down. So this time we will place the filter over here, okay, in this position. So let me remove this one. This will be the new position of the filter. Again, we will perform the same activity. We will place the result over here. We will move the filter towards right, and so on. We will keep on doing this activity till the time we are done moving this particular filter on this entire image. And this activity is also called convolving. So what we are doing is we are taking this filter and we are convolving it over the image like this, then over here, then over here. So basically, moving the filter on the image step by step is the activity which is called convolving the filter, and thus convolutional operation. Okay, so let me quickly erase all this first so that we can discuss ahead. So once the convolutional operation is fully performed and we achieve this particular matrix, which is called the feature map, which means the edge or feature that we are trying to detect will be reflecting on this particular matrix that we have achieved by convolving this filter throughout this entire image. And see, try to interpret this feature map very closely, and you will be able to understand that this matrix is giving us a vertical edge like this. It is because the intensity is changing in this area, and therefore your edge will look something like this. So in a nutshell, this filter or kernel matrix was successfully able to detect this particular edge, this particular vertical edge on the image successfully in the feature map that we have achieved towards the end. And the way this particular filter is designed, it is able to capture the vertical edge. Similarly, we can have a different type of filter that will be able to capture an horizontal edge. So let me show you how that filter will look like. Let me erase all this very quick. So this was the filter that we were using in order to detect the vertical edge. Now we can have a filter that looks like this. Let's say 1, 1, 1, minus 1, minus 1, minus 1, 0, 0, 0. You should use this filter and try to perform the convolutional operation on the top of this particular image. Do it step by step and try to gain a feature map like this, and you will observe that finally you will end up achieving an horizontal edge that will look like this. But before doing that, I would say that you should rotate this image to 90 degree so the image can become like this. Okay, for the time being it has only one vertical edge, so rotate the matrix in such a way that it should have an horizontal edge, and then use this particular filter in order to perform the convolutional operation so that you can gain a feature map that will have an horizontal edge. And if you were able to understand this entire thing, the convolutional operation, from a mathematical perspective, in that case, trust me, you have already cracked the code of CNN architectures, because this is the main idea of CNNs. At this point of time, you should have a very obvious question in your mind that in fact I had when I was learning this concept for the first time. And the question was that how do we come up with this particular filter? How do we decide the values within this particular filter matrix? And this is the fun part. You don't have to bother about that. During convolutional operation for feature detection, we start with random values for the feature matrix, which means initially these values could be anything. And then values are being adjusted using the back propagation depending on the image or the training data. Which means on the image, if you have vertical edges or let's say horizontal edges, then during the back propagation, the values of the filter will adjust accordingly in such a way that it should be able to detect those edges on the image. So for the time being, just relax, as you don't have to come up with these values on the filter that you will be using during CNN training. And yes, you may have this question in your mind that how the back propagation will work in this architecture. So do not worry about that, because obviously I have planned a dedicated video on that topic where we will learn in details that how back propagation happens in a CNN model. So for the time being, just don't worry about that. We will cover that for sure. But please make sure that you press the bell icon along with the subscribe button so that you can get notified once I'm uploading that tutorial. One more thing that I want you to understand at this point, that if your image has a resolution of n by n and your filter has a resolution or size of m by m, in that case your feature map will have a resolution of n minus m plus 1 by n minus m plus 1. For example, we have a 6 by 6 image here and we are using a 3 by 3 filter. So the size of the feature map will be 6 minus 3 plus 1 by 6 minus 3 plus 1, which is nothing but a 4 by 4 feature map. So please keep this formula in mind. It is important from the interview perspective, because personally I was asked during an interview that if you have an image of 12 by 12 and you are using a filter matrix of 4 by 4, then what will be the size of the feature map? So at that point of time, I was a little bit confused that what kind of question is this, or should I be having any clue around it? So with experience, I'm telling you that you may encounter this question in your interviews. But anyways, more important thing is that now we have a lot of clarity that how from a given image using a specific filter we perform the convolutional operation step by step, and how do we come up with a feature map. And this is exactly how the edges are detected. You can see there are various edges over here. Few are vertical, few are horizontal, few are slant. And as you move ahead within the convolutional layer, these edges will start forming more complex features like this. So you will start observing eyes, nose, mouth, and finally towards the end of the convolutional layer, you will start observing the entire overview of the image just like a human face. So this entire thing is something that happens when we are talking about this convolutional layer, this first part of your CNN architecture. Initially, it will detect edges like this. Moving ahead, it will start observing more complex features like eyes, nose, mouth, and towards the end, it will start detecting the entire face. This is how it works. And I believe that now you are comfortable understanding that what are feature maps, which is nothing but this particular matrix that we have observed towards the end that we calculated after doing the convolutional operation. And now you will be also comfortable with the idea of feature extraction, which is nothing but the concept of detecting various types of edges that will later on form more complex features that will ultimately give you the entire image. So let me clear all this to make it a bit clean. And now the last thing that I want to discuss with you is the convolutional operation in colored images. See, previously in terms of a grayscaled image, we had only one sheet or only one matrix of size 6 by 6, right? But this time, since we are talking about a colored image, then instead of being a matrix, this will be a volume of 6 by 6 by 3, because we have 3 sheets or 3 channels that will form a cube like this. Okay. And in this case, your filter or kernel matrix will also be in a form of a cube like this. So instead of being a size of only 3 by 3, this will be in a size of 3 by 3 by 3. So as a whole, it will also look like a cube. And now let's understand that how the convolutional operation is being performed in this case in terms of colored images. And since you have already understood the concept in terms of grayscaled image, this will not take much time to understand this particular point. So basically, the image that you have of size 6 by 6 by 3 can be considered as a large cube like this. Let me draw this properly first. So it is almost done. Let's see. Yeah, right. It will look like this. And the filter that you are going to use can be considered as a small cube. Okay, maybe like this. Let me draw this one as well properly. And basically, yeah, it is done. And basically now what you are going to do is you will convolve this small cubicle inside this large cube. So first of all, you will place it over here in this position. Okay, and you will perform the operation from here. So the same element wise multiplication and addition will happen, and the final value will be kept over here. Then you move one step towards right, do the same calculation and place the value over here. And this is how you finally come to the end over here at this point. So finally the cube, the small cube will be placed on the corner. After that, as a next step, you will come one step down, and now this time the cube will be placed over here. So I hope that you get the idea. It is very difficult for me to draw in 3D to make you understand. But if you have gained the intuition from the 2D or grayscaled images that how the convolutional operation is happening over there, then you will be able to understand this thing very easily. But please observe one thing over here, that your image has 3 channels, your filter or kernel has 3 channels, but the feature map will be in 2D, which means it will be in a form of only one sheet or 2-dimensional. This will not be in 3-dimensional like this. Okay, so let me erase this and try to understand why it is happening. Because when you are placing this small cube, this one, at the corner over here, then after doing the element wise multiplication and addition, you are getting only one single value, right? You're not getting the values in 3 channels or in higher resolution. This is why after performing the entire convolutional operation, your feature map will look like this. But let's assume one thing, and this will give you more clarity actually, that let's say this particular filter or kernel matrix has values in such a way that it will be able to detect the horizontal edges on the image that we have. Okay, in that case, you will get the feature map in such a way that the horizontal edge will be reflecting over there. And now let's imagine that you have another filter over here that you are using, which is also in a size of 3 by 3 by 3. And this time, this particular filter is responsible for detecting vertical edges. In that case, you will have another feature map over here, which will be in a size of 4 by 4, obviously, and that will reflect the details of the vertical edge. So you are using two filters. First is this one, second is this one. In that case, you are getting two feature maps. First is this one and second is this one. In that case, the size of your feature map becomes 4 by 4 by 2, because finally at the end you have two feature maps. One is detecting horizontal edge and the other one is detecting vertical edge. So this was the last and very important thing that I wanted you to understand. And this brings us to the end of this lecture. I hope that you were able to gain a good understanding, a decent understanding at least, around the convolutional operation, how it is happening inside the CNN architecture, and how we are actually able to detect various types of edges, whether it could be vertical, horizontal, or slant or curved edges. And you are not responsible to choose the value within these filters which are detecting the edges. These values are being adjusted automatically during backpropagation. So you just start with some random values, and this is the crux of the CNN architecture. So we started this lecture by dividing the entire CNN architecture in two parts. First was convolutional layer. Second was the fully connected layer. The fully connected layer is something that we are already aware, going by the concepts of artificial neural network. And within the convolutional layer, we have two types of operation. First is convolutional, that we have already understood within this lecture. And the second one is pooling, that we are going to discuss in upcoming lectures. Not only that, we will also discuss concepts like padding, strides, etc. that will give you more clarity around a CNN architecture. But for the time being, at least you should be clear till this point that the convolutional operations are responsible to give us the featured maps. Okay. And one more thing which I completely forgot to mention, that this first part of the CNN, which is convolutional layer, which is responsible for feature detection or creating feature maps, then what exactly this second part is doing, the fully connected neural network or the ANN architecture, which is attached towards the end. So basically, once you are done detecting the features on the images, the fully connected neural networks are actually used to do the classification of the images. So this first part is able or efficient enough to capture the features of a cat image or dog image. So it understands that what are the features of a cat, what are the features of the image of a dog. And finally, in the second part, we use a fully connected neural network or the ANN architecture that will be responsible for doing image classification or object detection. So this part will be able to tell you the difference between a cat and dog. This is in terms of image classification. Or in terms of object detection, let's say if you have an image where you have people like this and cars, although it is not looking like a car, but let's assume it a car. Okay. And let's say that you are using the CNN architecture where you want to detect all the cars within a given image. In that case, the convolutional layer can obviously do the feature detection for the car, or feature extraction, I should say, in better terms. But the second part, which is the fully connected neural network, will be responsible for the object detection within an image. So using the information or the feature details from the previous layer, ANN does the training in such a way that it will be able to do the object detection or image classification. So that is it. I know that it was a lot to consume, and most probably you will have to watch this video a couple of more times if you are covering the concept of CNN or convolutional operation for the first time. If required, please do that. Please watch it a couple of more times if needed, but it is extremely important that you get this particular idea of convolutional operation absolutely clear in your head. So today we covered a very important topic within the field of data science, within the field of deep learning, and in the upcoming tutorials, more interesting things are coming up. Thank you very much for watching till the end. You have a nice day ahead.